So I'm going to be talking today about navigating the future of AI-augmented research and education. Like William & Mary, Vanderbilt prides itself on doing both good research and good teaching. And so I've split my talk up into a first part that's going to talk about the research implications of AI augmentation, which I'll explain what that means in a second. And then the second part of my talk, I'm going to be talking about how I've been using AI-augmented techniques at Vanderbilt to teach my courses, which is a topic that's near and dear to many of our hearts. There's also a playlist with about 30 videos going through all the stuff I'm doing in this space. If you're interested, you can get that in the slides. So the starting point for this talk was a study I worked on over the last several years by the Carnegie Mellon University Software Engineering Institute, where I used to be the chief technology officer for a while during a sabbatical. And this was in conjunction with DARPA and NSF. And we were looking at what the future of software engineering was going to be. And the report, which you can get at this link, was published in November of 2021. And we talked about a whole bunch of topics, most of which I'm not going to discuss today, looking at advances that are going to take place in terms of development paradigms for building software, advances that are going to take place in terms of architecture for building software, and so on and so forth. We took a long view, trying to look out 10 to 15 years, and one of the things we did, because we thought we were taking a long view, is we came up with what we thought at the time was a very radical perspective that the current development model of software, which is mostly humans, will be replaced with one where humans work together with trusted AI partners. And we thought that's a good 10 to 15 year type of horizon to think out of the box. Well, exactly a year after we released the report, ChatGPT escaped from the lab. And unless you've been frozen in carbonide for the past couple of months, you know that ChatGPT is a generative AI technology, a large language model that appears and does generate new and novel content based on prompts that you give it. So this is taking the world by storm in a conversational manner. And suddenly the world was coming to an end. So if you look around and you Google, is AI the end of the world? You will find no end of articles that predict that this is the end of the world. And in the famous words of Ron Burgundy from Anchorman, boy, that escalated quickly. Now, the good thing about the world possibly coming to an end is it makes it very easy to predict the future of software engineering, because we don't have to think very far about it. However, I don't take that negative view. I believe that we're at the beginning of something really new and fantastic. 60 years ago, shortly after I was born, Stanley Kubrick released his movie Dr. Strangelove, which had the tagline, "How I Learned to Stop Worrying and Love the Bomb," because at that time we were living in the shadow of the Cold War, the Cuban Missile Crisis, and so on and so forth. My new perspective is how I learned to stop worrying and love the bot, the chatbot. So that's what I'm going to try to convey in my talk today. So our original study covered these 6 focus areas. 2 of them focused on AI augmentation, AI-augmented software development, it's a little hard to see this, and AI-augmented systems operation. And after spending some time thinking about this over the past few months, we realized this is actually a space with 4-fold different dimensions. There's degree of augmentation in the software development lifecycle, the tools and methods that we use to build software from low to high, and also the way we operate systems from low to high. Now, what's interesting about this, and there's a SCI publication that just came out a couple weeks ago that talks more about that. You can take a look here. Most software that exists today is in this part of that 4-fold table. Not using AI techniques, not using AI in operations. So for example, avionics mission computing, I've done a lot of work over many decades working with people building cyber-physical systems, distributed real-time embedded systems. Most systems are built that way. And so very interesting topics, still very important topics, but that's not what I'm going to talk about today. What I'm going to focus on primarily are building conventional systems using AI-augmented techniques. And I'll show you some examples here in just a minute about building things like mobile apps using AI tools and methods and techniques in order to make the apps better, faster, cheaper, more reliable, easier to debug, and so on. Of course, there's also systems that are AI-augmented that are built with conventional techniques, things like YouTube, with recommendation engines, with advertisements that try to be clever and figure out what you like and will then feed you ads that you might be interested in. But they're built with traditional tools. And of course, where we're headed in the pinnacle of success here, which is still kind of a pipe dream at this point, especially from a trustworthy point of view, are AI-augmented systems that have AI techniques that are built using AI tools. So a good example would be some kind of driverless car that uses AI techniques for verification, validation, development, and so on. The great thing about these techniques, as anybody who's played around with it any length of time knows, is the barrier to entry is exceptionally low. For basically a couple of cups of coffee, maybe 3 or 4 cups of coffee at Starbucks a month, you can go and get access to pretty much the latest and greatest in generative AI technology. However, we need to adjust our expectations accordingly. Lots of famous people, my colleagues, our colleagues, have gone on record saying all kinds of interesting things about these newer tools. There's an article that came out in a recent CACM by Peter Denning, an operating systems researcher and teacher for many years ago, saying things like this. Most of what ChatGPT generates are things that you already know. There's no radical departures from what others have already said. Frequent excursions into nonsense. Speaks with great authority, even when outputting nonsense. Now, what's interesting about that is that that was my experience my first semester as a graduate student. I didn't really know what I was talking about. I didn't say anything interesting or novel. Probably spouted a lot of nonsense and probably was very sure of myself at the time. It took me a little while to realize all the things I didn't know. However, nobody expected me as a first semester graduate student to write Nature and Science articles and get them published. Nobody expected me in my first semester as a graduate student to write successful proposals to DARPA and NIH and NSF. Instead, we worked together with my advisors and my teachers to do all kinds of great and interesting things. So I think we have to be very careful to expect the right things at the right point in this maturity cycle. Now, what's also important to recognize is what really matters here is not generative artificial intelligence, as if we're replacing people with computers or robots. It's really generative augmented intelligence, or AI+, which is people working together with these tools to get things more effective as an output. And that's what I'm going to focus on in my talk today. In some sense, you can think of this as like an exoskeleton for your brain. If you're an X-Men fan, you know that Professor X had this cerebro thing he'd put on his head, and he could do all kinds of great stuff. So I'm going to talk today about augmented software development and its impact that it's having in general on the way that we practice software. So I'll start with a pretty high probability prediction. If you ever studied, or if you ever watched basketball in the 1970s, you know there was a basketball player for the Philadelphia 76ers named Dr. J. And Dr. J's favorite shot was the dunk. And they said, Dr. J, why do you dunk? He said, it's a high percentage shot. So my high percentage prediction, and this is pretty obvious, is that these tools, generative AI, large language models, are and will continue to have a remarkable impact on the way that we build software in terms of being able to offload cognitive load from us and make us a lot more productive. And the reason why I know this is because I use these tools every day in my teaching and my research, and they make me ridiculously productive. They don't always work, but they're very good when they do work, and even when they don't work, if you know what you're doing, you can make them work quite effectively. So these would be things like GitHub Copilot, Code Whisperer, which is what I use because it's free, and other tools, Tab9, and so on. I'll be showing you some examples here in a second of how I'm applying these to my courses, but the point is that this stuff is coming into its own. It's being used and applied successfully. And the other thing to remember is not everybody believes this is happening, which is really kind of weird. So once again, if you study the history of computing, well-known people have said somewhat ridiculous things that they later came to regret. Thomas Watson, CEO of IBM back in the day, went on record in the early 40s by saying, there's a market for only 5 computers in the world. Not necessarily the best thing for people to remember you by. Bill Gates, one of the richest men in the world, went on record as saying, who needs more than 640K of memory? Bertrand Meyer, who's a well-respected computer scientist and software engineer, said AI does not help programmers. I think he's completely wrong. When people say things like this, it usually occurs for one or all of the following 3 reasons. Number 1, they're using the wrong tools. Number 2, they're using the tools that they're using incorrectly. And number 3, they don't actually program very much. Because if you program, you very quickly realize what programmers actually do, and you find this stuff is tremendously useful. So a lot of people have taken the approach of the following. It's kind of like a sculptor, think Michelangelo, takes a chisel, hits a piece of marble, and it doesn't instantly turn into the Pieta, and he throws up his hands and says, see, I'm no good, my chisel's no good, let's move on to something else. You have to do more than just a couple of whacks to get things to work. And so that's one of the other key themes here. And I'll talk about that in detail in a second, because I had that experience a little bit back. So here are a few key R&D challenges in this space. I have another video here that goes into a lot more, but we don't have time for that. So the first thing we're going to need to do is re-envision the way we build software. Those of you who've taken software engineering courses or been involved with software know that there's different parts of phases in the life cycle: planning, requirements, analysis, design, implementation, testing, maintenance, sustainment, and so on and so forth. One of the things that you realize when you start working on bigger projects is there's a lot of data that isn't code and isn't tests that are very important to make systems work out, especially larger systems, mission-critical systems, safety-critical systems, life-critical systems, and so on and so forth. For example, there's a nice article by one of my colleagues at CMU, SEI, who's looked at issue tracking reports and trying to anticipate through machine learning technical debt. Big issue when you start building large systems. More generally, however, there's lots of data that occurs throughout the life cycle that is far better managed and analyzed by AI-enabled tools than by people. And it doesn't take very long when you work in these big projects to see what's happening. For example, requirements, descriptions, test plans, architecture diagrams, the kinds of things you do when you're going out and putting out new releases, DevOps scripts, infrastructure as code, all kinds of things need to be analyzed in order to make a system work. And people, for better or worse, are not very good at that, especially on larger scale projects. And I believe that analyzing this data with LLMs, and I'll show you an example in a second, is the sweet spot for the current generation of these tools. And the reason for that is, unlike code generation or testing, where the gold standard is perfection, doesn't do much good to have a code generator or a compiler that works 75 or 80% of the time. That's not a good percentage. For these document and data analysis things, the yardstick is not perfection, it's usefulness. Because the other ways of doing it are people sitting around in groups not being able to make things work effectively. So I'll give you a nice example. I've been doing a lot of work recently with the Software Engineering Institute on nuclear surety. So these are for nuclear programs where you absolutely want to make sure things don't go boom at the wrong time. And they are incredibly strict and stringent with respect to the requirements and the way that people have to go about building these systems. There's a specification called the AFMAN for Air Force Manual 91-119 spec that specifies in rigorous detail all the things you need to do to build a nuclear safe system. What's fascinating about this is that really smart people have spent decades crafting this specification, and yet it's got lots of inconsistencies in it. Lots of reasons for that. Very few people have a brain big enough to read hundreds of pages and keep track of all the different stuff. Within a very short period of time, using off-the-shelf LLMs like ChatGPT 4, we were able to go through with the right prompt engineering and find all kinds of inconsistencies in that specification. And that discrepancy analysis, I believe, is one of the real winning perspectives and one of the winning approaches we're going to be seeing here for AI and software engineering. I'll show you another example in a second. So looking at documents, trying to find consistencies, gaps, other problems, that's going to be a big win because it's something where there's very little human ability and we can automate it. Another thing, which is a corollary of this, is taking the guidance from these documents and then being able to derive it into a form where you can check the code to see whether it conforms to those specifications. And there's all kinds of specifications out there that tell you how to write secure code for C, C++, MISRA, C, all these different subsets and profiles that are meant to make things more effective. And so what we're also working on are ways of being able to derive from these high-level specs, the requirements documents, the policy documents, executable checks to do discrepancy analysis on the software itself. And that is going to be a huge game changer. Now, you could go out and use tools like Coverity and other static analysis tools, but there's a couple of limitations with those, and I'll talk about them more when I talk about how I'm doing this in my courses. The main issues are the ways that you formally express things in these static analysis tools is mysterious to all but a few people who've taken formal methods training. And so you can't involve other stakeholders because they can't make heads or tails out of that. And it's also something that requires very expensive tooling that is difficult for many people to kick the tires on. So this is yet another discrepancy analysis approach that involves a broad range of stakeholders, and I'll talk more about that in a second. The second thing I want to talk about here, which I think is absolutely fascinating, is the emerging discipline of prompt engineering. So what is prompt engineering? Prompt engineering is basically structured ways of interacting or programming large language model computational systems. You think about these things as a computational system to solve very complex problems using natural language interfaces. That's the key thing, the natural language. The focus here is on problem solving, not programming in the traditional way that all of us who've gone to William & Mary and other places know and love for all the courses and work that we've done. Now, this problem-solving approach is also useful for software. So I'll talk shortly here about how we're using it for things like refactoring, code transformations, where appropriate, code generation, although that isn't necessarily the main focus. But it's also very useful for other things. By the way, I have a nice video here that I recorded the other day showing how I used ChatGPT to automatically refactor some tangled code that had things, different aspects woven together in ways that were inappropriate. And it magically generated a bunch of reusable classes and made things much more understandable and maintainable. The other way this is going to make a big difference, and this will matter for us from a broader view, broader societal view, is these approaches are really much more useful for other domains besides CS, where people need to apply computation but don't want to become programmers. Historically, when colleagues at Vanderbilt and elsewhere would come to us, computer scientists, and say, I'm a biologist, or I'm a chemist, or I'm a physicist, or I'm a classical civilization person who needs to analyze documents. I want to use computation to make my research better. What do we say? We say, great, I'm going to show you how to program in Python. God help us, I'm going to show you how to program in JavaScript, even worse, or C++, or whatever, or Java. And I'm not just picking on those languages. We tell them how to program. They don't want to have to program. They don't want to have to learn the obscure syntax of this stuff. They want to solve problems with computation. Before, the way to do this, if you didn't want to learn to program in third and fourth generation languages, was to apply domain-specific modeling tools, which is not a bad idea. The problem is that there's not a whole market for that. And so you typically, if you have domain-specific modeling tools, they're usually in very well-established domains like spreadsheets. And even if you build one for a particular domain, it's got a vanishingly small audience. It's hard to build all the other apparatus you need to be successful with a language like debuggers or training, mentoring, and so on. And nobody learns these things in school. However, LLMs make it possible for people who think systematically but don't want to program to become effective at problem solving. And I've got lots of other examples of that we don't have time to go over, but I'll be happy to talk about it later. What's also important in the context of prompt engineering are identifying and codifying prompt patterns. Those of you who build software are probably familiar with the concept of a software pattern or design pattern. I did a lot of work for many years a while back on software patterns, which are basically ways of trying to capture reusable solutions to common problems that occur within a particular context. And if you spend much time with object-oriented programming, you know about the Gang of Four book, the Design Patterns Catalog, and so on. It should come as no surprise, of course, that there's patterns of prompts. And so we have begun to document patterns of prompts for prompt engineering, just like we use for patterns of prompts in software development. And these are basically a knowledge transfer mechanism to work with large language models effectively. And we've been working quite a bit lately trying to codify patterns for prompting that work up the chain in the software lifecycle, because again, we think that's where we're going to get the biggest bang for the time investment. So you can take a look at some papers that talk about this. But the bottom line is, when people complain about language models not working effectively, it's almost always because they're using them incorrectly and they're not using the right prompt patterns. And so once you start to understand those, you can become wildly more successful and have your hallucinations come almost to zero. Another very important topic that we're just beginning to scratch the surface of is recognizing that building systems with prompts and prompt engineering is only going to work if we take a more holistic view of what it means to do prompt engineering. There's been a lot of pushback over the past couple of months where people say, oh, all these $300,000 a year jobs for prompt engineers, that's a fad, it's a flash in the pan. It's not going to pay off because LLMs are going to get so smart that with brain implants, you just have to think and it'll magically come up with a solution. First of all, that's not going to happen. But even if it were to happen, it's missing the point. When you start trying to engineer a system that has to live for a long time, you have the issue of testing, maintenance, version control, release-to-release compatibility. These are all the canonical quality attributes that software engineers worry about for building large systems. And people who use prompt-based systems are also going to have to worry about. So this is going to be important too. OK, so that was kind of the background. There's more to the story, but we don't have time. My videos have lots more about that. What I want to talk about now is the thing that's most exciting for me at the moment, which is applying all this stuff in my courses at Vanderbilt. So for the past 8 months, because that's about as long as this stuff's been out, I've been applying these techniques in my courses. I teach a bunch of courses at Vanderbilt. I teach a course that's for scalable microservices, where we build a really cool recommendation system for movie recommendations, and we use AI techniques in a couple different places. And I also teach a course where we build Android apps that do all kinds of cool things. These are upper-level mezzanine courses, which means grads and undergrads can take them, usually seniors and first-year grad students. This avoids some of the really thorny issues of how do we introduce this stuff effectively into the intro courses. Much, much more problematic issue because you really need people to know how to program before you tell them how to program by outsourcing part of their brain to a computer. Well, we may talk about that later. The overall goal I've had here is how do I take the things I love to do as a teacher and spend more time on them, and then take the things that I don't really like that much as a teacher, but I have to do, and get automation to help me out. So there's certain things I like. I love creating, giving lectures, creating and explaining code, making programming assignments, reviewing my students' initial submissions. That's super fun. I don't really like creating tests and quizzes, but I've got to, of course. I don't really like to make knowledge check questions. I don't really like to do the final assignment grading. I don't like to have to summarize the contents in my video lectures. I record all my lectures, and certain things are fun and certain things aren't. So I'm just going to talk about this one piece and how we're using LLMs to be able to automate the grading process. There's other videos that talk about the other stuff as well. So here's the problem, and I was talking to folks earlier today at various meetings, and you all have to start thinking about this if you teach courses, and certainly if you take courses. It is getting ridiculously easy to reverse engineer almost any kind of well-specified programming assignment that you can imagine, especially for the intro courses. And I don't have time to go into this in detail, but it was really exciting. One of my colleagues, he's a professor of the practice, a teaching faculty, he didn't want to learn anything about LLMs. We happened to be at a retreat a couple months ago, and I said, Jerry, have you tried ChatGPT? What do you think? Oh, no. Blah, blah, blah. So I said, well, send me the specification for your hardest programming assignment, which is this assignment. You probably can't read it, but it basically involves building what's called Guitar Hero Simulator, where you have to build a doubly linked list in a queue in C++, and then you go ahead and implement the Karpov-Strong algorithm to do simulating plucks on a string. Very complicated assignment. Many students can't finish it. Takes weeks to do. 7-page spec, very detailed. He sent it to me. We sat down together, ran it through ChatGPT. In about 5 minutes, it generated a perfect solution. He was watching as the code was, what ChatGPT prints out the code kind of slow when it comes out. So we were just watching together. And when we're done, he's like, wow, that's really good. I said, what do you think, Jerry? Isn't that great? He said, I think it's time for me to retire. That was not the answer I was expecting, but I think it's a good answer. So I thought, hey, I teach these really hard upper-level courses. They're parallel functional programming in Java with Android. ChatGPT is not going to be able to get my code. It's too hard. The night before my class this semester, I ran the code, my specs, through ChatGPT, and to my chagrin, it generated pretty much a perfect solution. So I thought, uh-oh, now we've got a problem. Now it's my problem. Well, the good news is, because it's a language model, I said, hey, ChatGPT, how can I change my assignments so it's harder for you to reverse engineer it? Kind of cool. And it gave me some really good answers. And one of the things it said, which is pretty obvious, is don't give such detailed specifications, because the more detail you give it, the easier it is to reverse engineer. So I said, all right, that's cool. So I stepped back and did a much more general purpose assignment. But now I had a new problem. Hard to reverse engineer, but much harder to assess. Because before this, I was using some really cool white box testing techniques and mocking to take my detailed program spec and then check student solutions to see if they conform to what I was expecting. But now the specs are a lot loosier-goosier, so it's easy for people to do all kinds of creative things, which is hard to check through mocking. And mocking frameworks also have some other limitations I won't get into at this point. Another problem, which you guys probably face, unless faculty here grade every single piece of submission by themselves, which is probably not the case. At Vanderbilt, we have an army of graders. We use a lot of undergrads as graders and a bunch of TAs. That's good, but then you have the problem with inter-rater reliability. Some people are easy graders. Some people are hard graders. Students get frustrated if they don't get the easy grader, right? Because it's inconsistent. Now, what I've decided to do is solve this problem through large language models. So again, ChatGPT taketh away, ChatGPT giveth. So the other nice thing about moving away from highly prescriptive specs is it gives students an opportunity to be more creative, which is just a good thing in general. So what are we doing here? Well, the way things work, in my class at least, is the following. Students submit their initial solution, and I review every solution by hand. fortunately, I've done this for a long time, so it doesn't take as long as it sounds. And so I review everybody's solution. I give them feedback. We use GitLab. I push comments back to their repositories. Then they get a chance to revise their solution. Then they submit it, and then the TAs and graders give them the final grade. OK. That worked when we had auto-grading for a lot of stuff. This is another example, by the way, of discrepancy analysis. So in the instructor review process, what I do is I look at everybody's code, and I note the common mistakes. People tend to do the same things wrong over and over again. And they have for years. So I write down a list of mistakes. I make a video, which I call the frequently made mistakes video. You can take a look at one here. But the problem historically was there was no way for me to be able to leverage that work from semester to semester. I would get a little better at finding the mistakes year in and year out, but I couldn't do anything else with it until now. So what we're doing now is we've trained ChatGPT to read the frequently made mistakes document and then generate a rubric that corresponds to the problems and the right solutions and then descriptions of what the problems are. So it's able to generate that. We said, hey, ChatGPT, what would you like the format to be for this? He said, oh, please use JSON. So we write it. It generates it in JSON. And then what we do is no longer require the TAs and graders to have to read my mind to channel their inner Dr. Schmidt to do the final submission assessments. But instead of what we do is we use ChatGPT as a static analysis tool. And we're automating this whole thing. And we take each of the student submissions, which should be pretty complete and pretty comprehensive, feed it through a Python script that talks directly to ChatGPT through the ChatGPT programming API. And you got to use ChatGPT 4 to do this. And it will then come back and find the problems in the code. And this is really cool. I don't know if we have enough time to do this. I've got a video that shows it, of course. But basically what you do is you tell it through prompt engineering how to read the code. You tell it what to look for in the code. And then you give it a list of questions. And I'll give you some examples of the questions. Question would be like, are there uses of the Java index-based for loop instead of using a for each loop? Are there certain method calls that shouldn't be there, because people tend to do things wrong in the same way? Are there certain methods that should be there that aren't? One of my favorite ones, for some odd reason, I like my students to write variable plus plus instead of variable plus equal 1. Just a weird quirk that I have. I was able to train ChatGPT to find that particular stylistic issue. And what's so cool about it was I said, are there any uses of variable plus plus, or any uses of variable plus equal 1 instead of variable plus plus? It was able to infer from my request image count plus equal 1, or foobar count plus equal 1. It knew how to generalize from my English language description. And so what happens is it runs through the code, comes back with a file that lists all the things that people have deviated, discrepancies between what I'm looking for and what they're doing. Now, one obvious question people always ask is, how do you deal with false positives? And there's a couple different answers to that. First of all, I'll explain in a second how we're able to get rid of almost all the false positives. Those would be places where the tool says there's a mistake, take points off, but there's no mistake. I'll talk about how I fix that in a second. But the other way to do it is simply to do the following. Whenever the TA or grader sees a discrepancy reported, they can go look at the code and see if there is a discrepancy. So that solves almost everything. And then, of course, the other approach is turn the solutions back to the students where they've lost points, and you will very quickly realize all the places you made mistakes. Because they will come to you and say, hey, listen, you didn't grade my program correctly. That hasn't really been a problem, but it's a nice example of how keeping the human in the loop can make a difference. This is the really cool part, and I think most people who have been naysayers about large language models have failed to miss this very important point. ChatGPT and other LLMs that are as sophisticated as it is are very effective at being able to help it do a better job. So what do I mean by that? Well, here was a problem that kept coming up. I was trying to not have my students use index-based for loops, because that is prone to off-by-one errors, among other things. And I just wasn't able to get ChatGPT to find the uses of the for each loops. I mean, the index-based for loops. It's like, this is really annoying. So then I said, well, it's an interactive model. So I said, hey, you're not finding what I'm looking for. Tell me how to ask my question better so you can find it right the first time next time. And boom, if you could read this, it says they're basically, the answer is almost always give more context. So whenever you have hallucinations, whenever you have problems where it's not finding what you expect it to find, give it some more context or ask it to give you more context. Now, how many other static analysis tools you've ever worked with in your entire life allowed you to engage in Socratic dialogue when you couldn't get them to do your bidding? I've never worked with one in my entire life that could do that. Or your IDE. If you're getting syntax errors with your compiler and you start typing into your compiler or your IDE, why am I getting a syntax error, right? It's going to be like, it does not compute. It has no idea what you're asking it. This is very powerful because you can engage in an interaction. And so by using the tools properly, you can avoid a lot of the things that people have come up with that they complain about. So a couple other things I'll note here real quick. This goes back to using the right tool in the right way. So when I first started, this was about a month ago, I sat down one weekend, I'm like, I'm gonna solve my problem with grading, I'm gonna use ChatGPT, and I couldn't get the darn thing to work. It wasn't finding anything, it was really slow. I'm like, the skeptics are right, why have I bet on this horse, this is terrible. So I called up a buddy of mine who's further along than I am, and he said, oh, first of all, don't use the advanced data analysis plugin, which is part of ChatGPT 4 Plus, with Java code. It doesn't work right. And it also doesn't understand context. So he said, cut and paste it or use the API interface and send your request that way. Boom. All of a sudden, it was like 95% correct instead of 0% correct. So use the right tool. And then the other thing, which I was just talking about, is learn to do proper prompt engineering. So when you run into these problems, you go back and you iterate with the tool and get it to do your bidding through Socratic dialogue. That solved like the rest of the problems. And then think about how people actually program, another important thing. So let's kind of wrap up and look ahead. So the original thing that we had said in our report from a couple years ago was the future of software will be one where humans and AI work together as trustworthy collaborators. Now, we're working together as collaborators. The trustworthy part is probably still the 10 to 15-year vision. It's going to take a while before we get this stuff to be trustworthy to the point where you would bet your life on it. However, when you put people back in the loop who know something, you can be quite effective. The tricky part is who knows something. So when I use ChatGPT, I don't waste time on rabbit holes and going down these long hallucinogenic experiences, because I pretty quickly know when it's not doing things right, and either I refine my prompt or I just say it's not ever going to work, I'll go on and try something else. Or I try another LLM, that's another trick. But we're getting to the point where we can do a lot of very useful things if you have the appropriate assumptions. So just try it, the barrier to entry is really low. If you look at the technological process and progress over the past 1,000 years, there have been a few major disruptive changes. The printing press, the invention of the steam engine, the invention of electricity, the computer and the internet. I think this is the next thing. And I'm so excited. This is like the most exciting time I've ever had in technology because we are at the point where we can influence the future, no questions asked. However, we have to be very sensitive to what I also believe is going to be the coming digital chasm. We all know what the digital divide is. The digital divide was basically there's people who have access to the internet and people who don't. And it's pretty clear. It's harder to be, you're probably better off as a human being, not being distracted by the internet. But it's much harder to do a lot of things these days as a teacher, as a student, as a professional. We're about to get to something even more dramatic, which is the digital chasm, where we'll have people who are very good at using AI, and they're going to be incredibly productive, and people who either can't or won't understand this stuff. And increasingly, it's going to be very difficult for them to compete in this brave new world. And that's where I think we come in, because we're going to see radical change. Computer science is in a somewhat envious position where we're more likely to know what's happening and more likely to be able to shape it in some ways. Other disciplines, like sociology, where I came from here at William & Mary many years ago, anything where you require writing as the evaluative discriminator between people's competency is going to be under enormous pressure. Because in the immediate future, and like right now, who generated that text? Good question. Almost everything is going to be generated with at least some help through ChatGPT, whether we like it or not. There's some people who hold out hope that maybe we can write tools that will identify ChatGPT written stuff or LLM generated stuff. That's hopeless. Very quickly, one of the things we were talking about earlier today, I can give ChatGPT all the papers, the 600 plus papers I've written, It can learn to write like me, and when I use it for whatever I use it for, it'll sound just like me because it's learned my form. That's kind of cool at one level. It's also very scary from the point of view of phishing and voice phishing and impersonations and deep fakes and so on and so forth and phishing attacks. But just be aware that we have to be very sensitive to this issue. There's a good quote that says, AI won't take your job, but someone who knows how to use AI better than you may take your job. And that's what we're likely to have. The last thing I'll point out here is, ironically, one of the most interesting things about the generative AI boom is that it absolutely leveled the playing field. If you had friends who were sociology majors and they wanted to get a job and they weren't going to go get a PhD in computer science like I did, you could send them to a boot camp and they would learn to become a web developer or a data scientist. But the problem they would have is when they came out to the workforce some 24 weeks later, there'd be people with 5, 10, 20 years of experience they'd be competing with. And the only thing they could differentiate themselves really is salary. There's nobody on the face of the planet, well, maybe there's like 3 people on the face of the planet, who have more than 6 to 8 months of experience as a prompt engineer. So it's a completely level playing field. Anybody who wants to jump into this can learn it. It's ridiculously inexpensive. You have a couple cups of coffee a month less, and you can do more with these tools. So it really provides an opportunity for leveling things, whereas before we didn't have that opportunity. So I think that's a really good thing to think about and be excited about. So with that, I open it up for discussions.